Wave nature of matter. The radiant energy has a dual aspects of waves and particles, and therefore from symmetry considerations de Broglie predicted that matter must also have dual nature under suitable condition. De Broglie made a bold suggestion that small particles of a matter such as electrons, protons and neutrons etc. have a corresponding property of behaving like waves. Matter in motion must be associated by waves called de Broglie waves. De Broglie waves derivation of wavelength. De Broglie equated that the energy equations of Planck and Einstein's and derived a relation between the wavelength lambda of a matter waves and a momentum of matter. The energy associated with each photon is given by Planck radiation capital E equal to h nu equation 1 where nu is the frequency. By Einstein's mass energy relation E equal to mc squared equation 2 where m is the mass and c is the velocity of light. From equation 1 and 2 we have h nu equal to mc squared. Therefore, Hc divided by lambda equal to mc square. Since nu equal to c by lambda or lambda equal to h divided by mc, put c equal to v, the velocity of the electron, then lambda equal to h divided by mv equal to h divided by p. Equation 3. The equation is known as de Broglie wave equation and lambda is called the de Broglie wavelength associated with the particle. Let us calculate the wavelength associated with an electron which is accelerated to a velocity nu by applying potential of v volts. The kinetic energy is given by half mv squared equal to ev or nu equal to root of 2 capital V into E divided by m. Substituting nu value in equation 3, we get lambda equal to h divided by m into root of 2 into V into E into divided by m equal to h divided by root of 2 VEm. Equation 5. The wavelength of electron moving with the velocity 500 kms kilometer per second can be calculated using equation 3. Lambda equal to h divided by mv equal to 6.626 into 10 power minus 34 divided by 9.11 into 10 power minus 31 into 500 into 10 power 3 equal to 1.45 into 10 power minus 9 meter equal to 1.45 nanometer. Taking h equal to 6.626 into 10 power minus 34 joule per second and m equal to 9.11 into 10 power minus 31 kg, the calculated wavelength of electron is of the order of wavelength of X-rays. This suggests that the electron, which is a particle of definite mass, moves like X-rays in the form of waves. Thank you.